Our chapter is Extraction and Corrosion of Metals. Chapter overview. Key learning objectives: understand metal extraction methods based on reactivity, explore extraction processes for different metals, analyze corrosion and rust prevention techniques. Metal extraction methods: reactivity based extraction strategies, extraction approach based on metal reactivity. Least reactive metals are copper, silver, and gold. They are found naturally uncombined in earth crust and have minimal processing required. Moderately reactive metals extracted by reduction with carbon, typically processed in blast furnace. Example, iron extraction. Then we have highly reactive metals require electrolysis for extraction, cannot be reduced by carbon. Example is aluminium. Now let's talk about iron extraction process. Primary ore is hematite. Blast furnace extraction steps. Carbon reacts with oxygen, produce carbon dioxide. Carbon dioxide further reduces the ore. Chemical transformation occurs at high temperatures, produces pure iron through complex chemical reactions. Now let's talk about aluminium extraction. Primary ore is bauxite. Electrolysis method is used. Aluminium oxide dissolved in molten cryolite, reduces melting temperature. Aluminium ions discharge at cathode. Continuous carbon anode replacement required. Corrosion and rust prevention. Rusting conditions. Key requirements for rust formation: presence of oxygen, presence of water, accelerated by salt, acid rain, and electrolyte environment. Rust prevention techniques. Barrier methods: painting, applying oil grease, plastic coating, galvanization, which is zinc coating. Advanced protection strategies: sacrificial protection, attach more reactive metal block, zinc, magnesium. Reactive metal corrodes instead of primary structure, creates protective electrochemical cell. Used in ship hulls, oil rigs, underground pipes. Emerging metal extraction challenges: deep sea mining considerations, polymetallic nodule extraction, potential source for rare metals, cobalt, nickel. Environmental concerns, technological challenges are there, and limited global mining locations we have. Some practical considerations are environmental impact of extraction, resource availability, technological limitations, economic feasibility of extraction methods. Now, let's talk about metal extraction and corrosion, metal extraction and reactivity series. Fundamental concepts: ore, naturally occurring mineral from which metals can be extracted. Very important. So, its ore is a mineral naturally occurring from which we extract metals. Extraction difficulty depends on metal's position in the reactivity series. Reduction process removing oxygen from metal oxide to obtain pure metals. Now let's talk about reactivity series principles. Most reactive metals combine most strongly in compounds. What's the carbon role here? It is positioned between aluminium and zinc in reactivity series, act as reducing agent for metals below it in the series. Now, metal extraction methods, we have carbon reduction method. It is used for metals below carbon in reactivity series. Carbon removes oxygen from metal oxide. Example, extracting iron from hematite. Second, we have electrolysis. Used for metal more reactive than carbon, requires electrical energy to separate metal ions. Metal gains electron at the cathode. Example, aluminium extraction. Next, we have experimental verification, carbon reduction experiment. Objective here is demonstrates carbon's reducing capabilities. Material used are copper 2 oxide, powdered charcoal, Bunsen burner, test tube. Some safety precautions: wear eye protection, handle chemical carefully, point test tube away from the people. Now let's talk about iron extraction in blast furnace. The key component here is the ore, which is hematite Fe2O3, furnace 30-meter steel tower. Raw material used iron ore, coke, which is a carbon source, and limestone, which is a source of calcium carbonate. Chemical reactions that happens there is carbon combustion. So carbon plus oxygen gives carbon dioxide and it generates heat for the process. Then carbon dioxide reduction to carbon monoxide. Then iron oxide reduction. Fe2O3 plus 3CO gives you iron and carbon dioxide. Then limestone decomposition. CaCO3 decomposes into CaO and CO2. And then in the fifth step, we have impurity removal. Limestone reacts with silica to form calcium silicate slag. Some blast furnace characteristics are continuous extraction process, temperature varies across different zones, produces approximately 95% pure iron, and waste gases used in heat exchange to reduce energy cost. Now let's talk about aluminium extraction. The extraction process, the mining ore is bauxite. We do ore purification and then we do electrolysis. Challenges: high energy requirements, typically located near hydroelectric power sources. Most expensive metal extraction method. Next, we have corrosion prevention, rust prevention methods, barrier protection by painting, by greasing, by plastic coating. Then we have sacrificial protection, using more reactive metals such as zinc, prevent iron steel corrosion through electron transfer. Then we have rust conditions. It requires oxygen, moisture presence, and electrolyte environment. Now let's talk about the problem of corrosion. Corrosion is a chemical reaction of metals with surrounding substances such as air and water. Then metals undergo corrosion, forming compounds on their surface. These are highly reactive metals like sodium, potassium require spatial storage condition. Otherwise, they will make the corrosion. Rusting. A specific type of corrosion is called as rusting. It is a specific corrosion process of iron and steel. Economic impact: significant financial cost for replacement and protection. Widespread problem in infrastructure and machinery. As they go rusted, it increases the cost for the industry. Key corrosion factors, essential components of rusting: water and oxygen. So it reacts, the metal reacts with oxygen or with the water, okay, to form the rust. Accelerating factors, salt presence, especially seawater. So the metals which are near the seawater in homes, for example, they got rusted a lot more or more faster as in those homes which are away from the sea. And it also causes acid rain. Metal corrosion variation, aluminium versus iron corrosion. Metal, aluminium. Corrosion behavior is it forms thin oxide layer, and to protect it we have self-protecting surfaces. Iron, it forms flaking rust. Continuous metal degrades due to this rusting. Now, protective metal strategies, oxide layer protection. In aluminium, thin oxide layer prevent further corrosion. Chromium, similar protective mechanism like aluminium. And then we have stainless